Hello, everyone, and welcome to November's Café with the CRC. I am Dr. Alison Justice, and I'm going to be talking about trichome physiology and go over our side lighting study that was just completed. Looking at these trichomes, they're beautiful. They look like little Christmas lights or mushrooms or water droplets. The closer you get, the more intricate you realize they are and really delicate. Whether you realize it or not, we are cultivators of trichomes. These are what we care about. This is where the secondary metabolites that are so important are formed and created and held. But we have to dry out this plant where it will be shelf stable. So, how do we desiccate this plant without destruction? How do we dry the plant without rupturing cells or knocking trichome heads off or destroying what we're trying to grow? Is difficult. I'm going to be showing you quite a few pictures and videos that really help, at least me, wrap my head around what's going on and how these things work. But if you don't know already, check out Eric Nugshots from Instagram. He is a cannabis photographer, and you can really learn a lot by the pictures he puts up, and they're just beautiful. I selected this shot because there are tall trichomes, there are short ones, they are golden tops, cloudy. We've got desiccated senesced trichome heads. It's all over the board. And so, preparing for this talk and studies that are coming up, reading through the papers, it has been absolutely fascinating. Really getting to see an industry that is new and where we do not understand exactly what's going on yet. There have been a good many papers put out about trichomes and their physiology and how they're produced and what's produced, but still, even to this day, even with a 2023 paper, looking at it, there's a lot of contradictory going on with the information. And you can really understand why. I mean, these trichome heads are so small. How do you sample just a trichome head to understand what's being produced in certain areas? It's difficult, but it can be done. Yeah, I just wanted to set up the next slide with this picture of real life trichomes and what they look like versus cartoon drawing. But many times the cartoon drawing can be a little more clearer in what you're trying to see and explain. In the last slide, you saw different sizes, different types, etc. Well, as I was talking about the discussions going on within these peer-reviewed journals, is contradictory, and mainly that is about the difference between these trichome types. What comes first, the chicken or the egg? Are these completely different structures that will never mature past? Looking at this cannabis sessile trichome, will it turn into a stalked trichome? There was a lot of debate back and forth about that, but the most recent paper shows and gives good evidence to say that the sessile trichome actually is just an earlier version of the stalked trichome. Very interesting to see that debate. And of course, only in a science field this new and fresh would you get that blatant of contradicting each other. As the cannabis plant goes deeper into flower, the epidermal cells begin to peak. And this on the left is a picture of that, the early formation of a creation to become a sessile trichome. From there, the secretory cells are formed and the trichome head begins to expand. epidermal cells continue to push up to make longer and longer stalks. But all in one is the same trichome, is just a progression of age. Now, going back to the secretory cells, you'll see down here it can range from 8 to 13, etc., etc. This is where all the good stuff is made. This is where the terpenes, the cannabinoids, everything is manufactured in these cells and then sent upward into the glandular part where it is stored. And the real question being, how do we protect this structure? How do we keep the cuticle intact? How do we keep it from rupturing or being compressed or being knocked off? It's difficult, but it's possible. And with better imaging software and tools, we can begin to monitor and really see what processes we have within cultivation and post-harvest handling, what is being done to those trichomes. So you'll see in the top right, this is a trichome stalk where the head has been knocked off. And so you can see just the small amount of tissue where there is attachment to the stalk. That bottom picture under it is a trichome head turned upside down. So you're able to see all these secretory cells and the big balloon of a stuck trichome head. I think if I don't stop myself, I would say that every one of these images is my favorite, but this one is great in that it truly shows, due to fluorescent imaging, it shows in these trichome heads where are their actual cells. This is highlighting the nuclei. Here, you're really able to see breakdown within that trichome cells of bubbles. And so these bubbles would be different secondary metabolites that are produced. And obviously, each trichome, right side by side, looks a little bit different. Same thing here on the bottom, where you get a very nice view of, this balloon, where here at the bottom is where everything's being manufactured and shot up into and inside of the cuticle. Now we're going to talk about the progression of senescence. When do you harvest? What indicates harvest time? Is it the stigmas? Is it the coloration of the trichome heads? What has been quite interesting, not only with my time looking at these with the SEM, but also going through some of the past papers, is how similar these are to, as simple as it may sound, a balloon on a stalk. When a trichome head stalk is turgid, is fresh, what you get is a very clear, round balloon shape that's not sagging. As the trichome heads progress, as the plant is starting to dehydrate, what you get is this balloon structure compressing down and looking a little more like a mushroom head. This is a great example of, it already starting to slumping down a little more, and to where you're really able to see those bubbles, those groups of metabolites within the trichome head being outlined because that cuticle is compressed down onto those bubbles. So that's what you're seeing here, which are these dots when you're looking at a nice and fresh trichome head. So what we don't want is the trichome graveyard. The wrong drying and curing post-harvest treatment of trichomes, you can very easily end up with something that looks like this. I don't think it takes a professional to understand that these have really been abused and they're covered with some sort of fungus. Now, I love this picture because When I first looked at it, all I could see was Ursula's Lost Souls. And so that's why this is on there. But in reality, they do look like they're screaming, and it is because they are so unhappy. But no, in reality, this is extreme damage. This was took from hemp that was grown outdoors. You know, it was abused, and this is what you get. So, this is what you do not want on your cannabis, and we can certainly do better than this. I'm going to take a step back and explain what SEM means, scanning electron micrography. So this isn't actually an optical image. It's basically math that's giving us these images. You're not seeing it directly through a lens. What you do is you dry your sample. It's coated with a metal, usually platinum or gold, and then electrons are thrown at the sample. Whatever bounces back is captured and computed. And so that computed image is what you see here. Now, we see the trichome stalks here that are nice and plump, turgid, and that is because this was a sample that was dehydrated and processed wet. The damage on the trichome heads here are from prior treatment. So maybe the fresh bud was rubbed on the ground or who knows what. But when you see trichome stalks that are shriveled, that's because these cells have dehydrated and shriveled down. There's no avoiding that. But what can be avoided is the treatment of these oil structures, these glands that are at the end of the trichome stalks. They're what we're most concerned about. You can even see in this picture where some have touched each other. They expand and they expel this resin that's inside. But if you remember, I said they are coated with platinum. So there are some details that are skewed, especially when you zoom in more than this, with this representing, I don't know, 40 or 50,000 times zoom, which is a lot. As you can imagine, those metal particles, the lower in zoom you get, the more chance there is for that to be round, those crevices or whatnot to be rounded out. And so that's why these aren't, you can't perfectly see the outlines. But we're going to go to Instagram and look at a video to show where you saw in the last picture of the trichome heads touching and combining, what that looks like if the plant hasn't been coated in platinum. So look right about here, and you'll see this trichome head actually release the resin from within. So this being a live plant, who knows why it could have ruptured, it could have been brushed earlier, or maybe the environmentals are extreme. Here's a couple more SEM shots, but this would be a flower that has been dried. I believe it was somewhere around 60. The stalks have dehydrated and shriveled. Standard, there's no getting around this. These ultimately are just considered plant cells, whereas these glands here are more of the resinous structures. In this picture, you see these trichome heads have been maintained, some better than others, but there's no bursting or cracking of the trichome heads. Here on the photo on the right, you see where a lot of crashing into each other has happened, where the resin is coming out. Now, you've got to think about this. If the resin is coming out of its container, the cuticle, then it much more easily can evaporate. meaning it leaves the plant where you're looking to extract it from. So this is something to think about when you're drying and you have a lot of aroma in the air. If it's in the air, well, maybe that means it's not necessarily in your plant. Maybe that's because your cuticles have ruptured. Um, Aggressive drying and cracking could certainly cause this. So thanks again to Eric, who provides really amazing pictures and videos. This is a stacked image of about a 48-hour span. He says that he did keep the camera going longer, but after this first 48 hours, there was no more movement. So the stalks are dehydrating, curling, repositioning, whereas the trichome heads, if not destroyed, are quite maintained. This video shows just how delicate trichome heads are when they're live, when they're fresh. Just the touch of a pencil, barely touching, and they burst. So you can imagine when they touch each other after you've harvested the plant and you're dragging it across the table, all of these touches can really alter what you're able to extract from this plant or what will be there in the raw flower form. Once they are dried, they are, that should almost looks like mercury. Once they are dried, they do not act quite in this manner, um, but are still quite delicate. Now, the journals called these structures bulges, but I'm not going to do that. This is where resin is escaping. And here we're looking at the progression of senescence. So we have escape happening, we have cracking. You can see here the cuticle actually is torn as the insides of the trichome head are being released. The cuticle actually shrinks down around the resin that's left inside. I would guess the non-volatile or less volatile components. Here in the last picture being full senescence, where um, you really have nothing much left inside. Now, obviously, there is something left because even hemp that's dried in the sun, you can get some sort of terpene extraction out from it, but it's significantly less than if trichome heads weren't destroyed in such a manner. The way I think about it is if you have a trash bag or a grocery bag and you fill it with water, if you take your hands and squeeze it, you may get the majority out, but there's still going to be a little bit left inside. There's a lot of crevices and parts for it to hide behind. Dr. Punja's latest paper didn't really focus on this, but I thought it was a really interesting concept and something that I certainly hope he expands on and we learn a little more about. So this was a supplemental photo for his paper listed below, but the thought is, well, are there actually pores in the trichome head? And we don't know. He presents it as a question. And how do these pores act? Are they like stomates where they can actively shut and open, or are they passive? We're not quite sure, but with the way that we can actually see the resin coming out of the trichome heads, it could be likely that there are pores. And when there's pores, we have a little more control Just like in stomata, there's certain hormones or certain environmental treatments we can do to help keep those pores open or closed. So still a lot to learn, but very exciting. We're getting down to it. Now, trichome maturity and size, this paper really looked at imaging and being able to say or follow the progression of trichome maturity based off of coloration. Now, we've all seen and looked at trichomes under the microscope to try and understand when to harvest. And in this paper, which I would encourage you taking a look at, they do correlate maturity with coloration. And it's very different for different varieties. So, eventually, as we keep growing as an industry, being able to have tools like this that you just take pictures of, and it tells you, of what course you're on with maturity with your certain variety, and understanding in that manner how to harvest, could be extremely helpful. Now, here's looking at the correlation I was just talking about with different varieties. Here on the bottom axis, you'll see DAF, so that's days after flower, and then phenotype probability. There's a very clear correlation of flower maturity with a decrease in clear trichome heads. And where that intersection of milky and clear happens at different days after flower within these different cultivars. But I think what is pretty obvious is looking at progression of brown trichomes is slow. Not quite as much with the Afghan Kush, but is slow and then is rapidly increasing. So I think this really demarks true senescence, and which in this paper they show correlates with the decrease of cannabinoid content. Now, I think this was kind of random, but really neat to see. In the same paper, they took a look at the application of millstop, which is potassium bicarbonate, and how that affected trichomes with color and size, etc. Graphed on the left, you'll see the three colors, which indicate clear, milky, and brown, as well as the W meaning water and the M being the millstop. The differences in clear trichomes are not statistically relevant, whereas milky, you have significantly less milky trichomes with the application of millstop, but then you look at the brown trichomes and they're much higher with the millstop application. Additionally, the density of trichomes with and without millstop treatment was significantly different. So a lot less trichomes with an application of this potassium bicarbonate, which is very likely something that you may use in your IPM rotation. It's something that the CRC is planning on doing, is really evaluating different treatments, whether it be different types of drying and curing, or whether it be a pesticide application. What do these treatments do at the microscopic level? Are there residues left? Because that can be checked with SEM work. Are there destruction or explosion or misshaping happening from certain applications that are done? Um, and so that's really exciting. Not only that, but looking at trichome density for different varieties. Um, Trichome density versus trichome head size. All things that can be looked at, can be quantified, and can help you with breeding or simply which varieties to grow for certain reasons. Additionally, in this study, they looked at plants that are infected with the hip latent viroid, So obviously healthy and stunted, but you're seeing the same thing in that there's a lot less trichome density with the virus versus without. Now let's wrap this up with the chart that I know you all know and love so well, and think about pressure and drying and trichome heads and how it's all affected and how they all are relevant to each other. Now, in a traditional dry room, you have your HVAC, which cools, and sometimes also dehumidifies, depending on the type. And then you have your dehumidifier, which brings the moisture out of the air, but also warms up the room. So you have the HVAC and the dehu battle continually happening. So you have peaks and you have lows, and it's continually changing for that plant. Well, you also have to think about that plant itself. It is losing water very fast, most likely. First couple of days of drying is when it loses the most water. So the internal pressure of that plant is changing rapidly, continually, as well as what's in your dry room continually changing. So let's give for an example, you are in a room where you're somewhere around 60 degrees Fahrenheit, and when your dehu is on and working well, let's say you're able to get it to about 40% humidity. You're looking at a KPA of around 1. And then, of course, when your HVAC system says, well, it's really hot in here now, we need to turn on, it's cutting the dehu off. Well, what happens is your humidity skyrockets and your VPD, your KPA, it changes drastically all the way down to 0.26. So those numbers may look very low, but if we convert them to PSI, you see that the difference is almost 4 times. And so that could be within minutes of each other. Uh, that could be within minutes of each other. The zombie plant is receiving pressure from the outside environment. It also has its internal pressures, which now is very different because it's not connected to the plant. Um, and it's ever changing because this plant now has no roots. We're forcing water out of it. And with any living thing, as water is removed, the skin layer or the cuticle layer on a plant, it becomes more fragile. And so as these pressures are moving the insides and outsides, the chances for rupturing or cracking the cuticle and the cell layers is much higher. In this study, we use Grow Light Design's lighting system. You can see them in the picture. They look like some sort of PVC, which is covered on the inside with LED strip lighting, and it's double stacked. They come in 4x4 sets, and you can make them go as long as you wish. They do hold trellis if that is of desire. I don't think it's any surprise that with higher light intensity comes higher yields. With blueberries, blackberries, strawberries, many crops, including cannabis, has proven this scientifically. So what happens when it's not just an increase in intensity, it's simply a redistribution of the light from the top to the sides? So we look at this, and of course, to understand what changes happen, we look at the wet weights, the dry weights, cannabinoids, and really looking at the ratio of smalls to premium. It makes sense if you're taking light from the top and putting it on the sides, which usually receive lower light. You certainly could have a greater mean weight of what would be your smalls now might be your mediums. We all defoliated these plants as normal. Of course, that would have to be a practice that happens to make this work because leaves can block a lot of light. So there was one large defoliation at about week 4 for everyone. So I just want to make sure everybody understands what I mean by redistributing light. So it's taking it from being 100% of light provided by the fixture above to a portion of that light being redistributed to the sides. And so that 100% that's on top is dimmed or raised, and you're only providing 80%, whereas 20% is going on the sides of that plant. Now, that's not the breakdown exactly of what we did. That's just a very easy, quick math representation of what I mean by redistributing. The average yield from each plant with and without this inner canopy lighting was drastically different. It equated to about 20%. What's neat to see here is the 20% difference, not because 20% more light was added or even any more light was added. It was simply a redistribution of light, which equates to a redistribution of energy. Um, it's pretty cool to see that you're not having to put more electrical cost towards an increase in yield. There is the capital cost of buying these inner canopy lights, fixtures themselves, but with the difference in yield production, it certainly could be worth it. Something we did not include in this study was looking at the labor of taking these fixtures down or putting them up. It is certainly something to consider, but with the true difference we saw with the fixture and without, it certainly would be worth getting some of these fixtures yourself and seeing how you can implement it into making sense on a commercial scale. That's it for this month. I hope you enjoyed and learned a little bit more about trichomes that maybe you didn't before. And hopefully, we've at least put a bug in your ear to start thinking about inner canopy lighting. Always something to think about.